I'm delighted to say what we're doing in quantum technology at VTT. Okay, there's already the introduction on what we do, but there we are up in the north of Europe. We're 100% owned by the Finnish government, Ministry of Economic Affairs and Employment. So in some sense, a government research lab where we do research, development and innovation for our partners, with a turnover of about €250 million, half of that coming from abroad. And we've been at it for about 80 years with around 2,000 employees at the moment. And where do we sit in the innovation platform? Well, we try to be in this sweet spot between what the universities are doing in the basic research, so chip scale, one-of-a-kind proof of concepts. And we try to take that and make it into a scalable, hopefully at least wafer scale and reproducible technology that can be applied for the customer's applications and then transfer that into the industry. But we also work the other way around. So we can work with our industrial partners and do more cutting edge or high risk research projects. And we try to be in this sweet spot where we think the real innovations are born and nurtured. So in short, what do we do? Well, we have all the necessary experts, around 250 of them, about half of them with PhDs, across the spectrum of microelectronics and quantum technologies. So we do everything from 6G technologies to various sensing solutions, all the way to quantum hardware, mostly superconducting quantum hardware and some photonics at the moment. And recently, together with IQM, we have co-developed 2 in-house quantum computers with a 3rd one on the way. And we offer those with our partners to develop quantum algorithms and software solutions. So we really span the whole gamut of microelectronics and quantum technologies, and of course develop quite a large IPR portfolio as part of that we are constantly licensing out to try and make impact. It's also worth saying we operate the largest R&D cleanroom in the Nordics, that we are happy to work with our partners to develop their solutions. Speaking of solutions, so superconducting qubits, we are mostly working with these aluminium Manhattan-style transmon qubits that are quite popular in the community at the moment. They seem to have the highest demand at the moment for let's say, our fabrication services, and our coherence times seem to be around this few hundred microsecond range, which seems to be reasonably okay. But we are not super happy with that. We are trying to develop technologies to go beyond aluminium, to go beyond the liftoff process, maybe with some X junctions, and to make them more compatible with going to high density, for example, through 3D integration. Speaking of 3D integration, we believe we have one of the best offerings in Europe in terms of our superconducting 3D integration platform. So we have superconducting through silicon vias on a 6-inch platform, and also superconducting flip chip. And we're developing various other technologies like solid state cooling and so on that we think will also be useful for the field deployability of QPUs and quantum technologies with superconductors. We also do quantum sensing. In fact, this is the oldest quantum technology at VTT. So for the last couple of decades, we've been developing squids for medical and space applications, and also SNS PDs. These have seen quite a boom in recent years with lots of material development going on. And perhaps the most exciting topic for me personally is that we have a 6-inch wafer process for superconducting graphene, where we've been able to make Jorden FETs and bolometers with this technology. And we're actively looking for partners to commercialize this. We also have some cryogenic electronics. So we have a lot of experts working on, let's say, higher frequency, the K and W band applications. And we've been developing cryo-CMOS and silicon germanium techniques for making cryogenic electronics. And we believe we have one of the best low noise amplifiers in the W band, which may be of some interest for future quantum technology developments. I'll also advertise that we have ultra low loss silicon insulator photonics platform that we are constantly developing, and various optical packaging solutions as part of this that we are offering to all of our partners if they are interested. So how do we work together? It's typically through these comprehensive research and development projects where we can do design services, fabrication services, and measurement services, whether that's on the prototype level or even low to medium volume manufacturing. And that's really what I wanted to say in these 5 minutes. So if you're interested to collaborate or co-develop something, please do get in touch.